lesson number 1, we are going to be talking about our polynomials, okay, of degree 0, 1, and 2. And you might be thinking, I have no idea what that means. So let's take a look. Let's refresh, because you would have learned some of this in grade 10, and you would have seen it again last year. So here is an example, okay, of a polynomial. Polynomial just means many terms, okay? And all of these, you're going to see, can be graphed, and they're going to look like certain things. Okay, some of them are going to look like a straight line. Some of them are going to look like what we call a parabola, right? So some of them are going to, ooh, that's really thick. Give me a sec. Okay. Right? So some of these are, okay. Hey, you guys need to take a moment? Okay, or let me in on the joke. Maybe not. Okay, so this is a parabola. Okay, we dealt with these a little bit in grade 10, okay, but mostly in grade 11. And we're also going to see things that do this. Okay, that's what we're going to be looking at. But for today, first of all, we're just going to define what is a polynomial, okay, and what is maybe not a polynomial, and then graphing these and just describing some of the behavior. Okay, so you'll notice that, okay, poly means many, there's many terms. So usually, you noticed in our last unit when we wrote out the quadratic formula, we wrote it ax squared plus bx plus c is equal to 0. Okay, so just a reminder, we talked about this last unit. If you hear me say the leading coefficient, that's just the number that's in front of the x squared, right? That's kind of like the first number. Okay, the other number is also called a coefficient. It's just not the leading one. It's just a regular coefficient. And this final number here, okay, it doesn't have a variable, so it's just called a constant. Okay, so here we go. When we have, let me get my notes. Okay, when we have a constant, like for example, y equals 7. Okay. There's not even an x value, okay? However, okay, if you remember your invisible math, okay? Because assumed math, right? If I just gave you an x and I said how many x's are there, you'd say, well, there's one x, because everybody knows that there's a 1 if there isn't anything written in. That's what I'm talking about by invisible math. Hey guys, if you just see a number, okay, this is exactly the same thing. If I multiply that number by an x to the exponent 0, anything to the exponent 0 is equal to 1. Okay, so this is why this is considered a degree 0, is because we could have written in an x with an exponent 0 next to our constant number. So if you don't see a variable, if you just see a constant, just know that this is degree 0, okay? Degree 1, this is an example of degree 1, because again, this is that invisible math. If we don't write an exponent, it's assumed that there's a 1 as the exponent. Okay, this is an example of a linear line. Linear just means straight. So a degree 0 is just going to be a constant. It's going to be like a flat line. Okay, this one just happens to be y equals 7. Y equals 7 just means that it is 7 all the time. If we wanted to take a look at this, okay, on our graphing calculator, okay, I'm just going to clear out what I had. You just put y equals 7 and graph it. There it is. Y equals 7. Doesn't matter what x is, you're just going to get a straight line, a horizontal straight line. Okay, a linear line, okay, still a straight line, but now it's got a bit of a slope, right? It just angles a bit. So 2x plus 7, okay, what that looks like is 2x plus 7. Okay, this is your straight line, okay, but it has a little bit of a slope to it. Okay, a quadratic is our degree 2, and this is what I showed you up here. This is the parabola. This is our quadratic. I'm having technical difficulties today. Seriously. Okay, we're just going to have thick lines today. Sorry, guys. Okay, and then we're also going to be looking after our unit test, we're also going to be looking at degree 3, which is called the cubic, and that's what this guy is here. This is our cubic, where it kind of goes woo, and has a little bit of a, yeah, exactly. You just remember that, and you got cubics all set. Okay, here's what is not a polynomial. Okay. All right, go away now. Now that we're fixed. Okay, guys, a polynomial, no x's on the bottom. Okay, so all those rational expressions we were doing, those are not going to, we're not going to be graphing those. Okay, so if you want to put in here, so no x on the bottom. Okay, or negative exponents. Okay, like x to the negative 2. That's not going to be a polynomial. Okay, guys? No decimals. Okay, or fractions. Okay. Okay, like that. Okay, we're not going to be looking at anything with the square root. So, no square roots. Those are not our polynomial. And, okay, no no variables in the exponents. We have a whole separate unit on that. No variables. Let me spell that right. So if there was, okay, if there was a variable in the exponent, we would call that an exponential function, and we're going to be studying that next. Okay, but for this unit, these are, just so you know what is not a polynomial, okay, all of those examples. So what we're going to be looking at is we're going to be looking at ones that have either degree 0, degree 1, degree 2, or degree 3. Okay. So now there's like a nice written description. We're now going to like put in a couple examples and give you words to describe these. So polynomial functions of degree 0, also known as a constant function. Okay, a function that contains only a constant, so just a number, there's no variable. Okay, for example, y equals negative 2. So guys, if you were to graph this, okay, you could do this. Okay, so I want you to graph it. You're going to label it y equals negative 2. Your line is going to have arrows at both ends and extend past the grid. Okay, make sure it goes past the grid. Okay, don't forget that this axis is your x. The one that goes up and down, that's your y-axis. Okay, so this is a horizontal line. Okay, you guys are writing these descriptions in. You remember domain and range? Okay, they're coming back. So the domain, think of yourself, okay, you are the king or queen of your castle and you are looking out over your kingdom, you're looking out over your domain. Okay, that's a horizontal thing. You're looking at your domain. So domain is any restrictions on x. Okay, in this case, x can be any value. It can be positive, it can be negative. There's no restrictions on x. So we write it like this. Remember, we do the curly bracket, x such that x belongs to real numbers. End curly bracket. Okay, so this means such that, okay, belongs to is this, okay, it's a Greek letter E, it's the epsilon. Okay, and then this is real numbers. Okay, it looks like an R, it just has a double bar for the R. If you just write a normal R, that's fine. I'll understand what you mean. Okay, but you'll see that I write it as a double bar. Okay, our range. So think of this as a temperature range, right? And you're looking at a thermometer. A thermometer runs up and down, and so you're looking at range as your up and down value, okay? In this case, okay, the only value in up and down is, like it's always going to be at y equals -2. So in this case, y such that y is equal to -2. That's the restriction. Y is always going to be -2, no matter what. X can be anything. X could be -10. Y is still going to be -2. Okay. Are there any x-intercepts? An x-intercept is where your line crosses the x-axis. No, not in this case. Not a single one. Okay. What is the only time there would be an x-intercept? Like for a horizontal line. Yeah. Okay. They surprise themselves. Okay, so here, okay, sorry, no x-intercepts. Let's get this spelled right. X. No x-intercepts. Okay. Okay, so hey guys, so this is interesting to note. So there are no x-intercepts in our example here. So the only time that there would be an x-intercept is if the horizontal line was actually y is equal to 0, and in which case it would have infinitely many x-intercepts because any point of x would be considered an intercept. Okay, page 2, maybe like bookmark it or put a little sticky on it because you'll be coming to page 2. This is your reminder of how to use your calculator for all questions in this whole unit. Okay, so I will probably be jumping back to page 2 when we start a new concept just to make sure that we understand things. So let's review this. Steps to using your graphing calculator. So don't forget, when you see an equation, right, your y equals, you're going to press y equals. Okay, so that's what we did, right? We have our y equals. Make sure we know where that is. Okay? And then you're going to press graph. Now, guys, if you have previously done something and your graph looks a little wonky, or maybe you're doing homework, right? We have to change the window settings. If you ever need to get back to your normal window settings, don't forget you can do Zoom 6. Zoom 6 is, if you look at what 6 says, it says Z standard. Okay, Zoom 6 will always get you to your -10 to +10, -10 to +10. Okay, so if you don't see anything on your graph, you have to check your windows, and sometimes you just need to reset it. Okay, Zoom 6 is really handy for that. Okay, adjust your window settings. Okay, so we'll play with this a little bit as we have questions. So just remember that if you hit Windows, right, you can adjust them as you need, right? You have your X minimum, which is on your left, your X max, which is on your right, your Y min, which is your bottom, your Y max, which is your top. Okay, so let's remember, okay, when we're entering our Y equals, okay, guys, don't forget that this is the, say we were doing that, how about we all do that 2x, okay, plus 7. So the x that you want to use is right beside your alpha key. right? X, T, theta, N, that's what the button says. That's how you get your X in there. We're all still good with that, right? Okay. All right. Do you guys remember quadrants? Okay, which one was quadrant 1? Top right. Okay, this is your quadrant 1. And then we go around counterclockwise. Quadrant 2, quadrant 3, quadrant 4. Okay, we'll need to remember quadrants because when we're describing our graph, we're going to be reading it from left to right, and we might say it's down in quadrant 4, up in quadrant 1. Okay, and that will help us to determine that it's going down here, but up here. So that would be a great description of our graph, right? It's down in quadrant 3, and it goes up to quadrant 1. So we're going to be using a little bit of quadrant vocabulary. Okay, we'll come back to these when we have an actual example, but it will help us when we're trying to determine y and determine x. Okay, we have to remember what our y-intercepts are and our x-intercepts. Okay, and then also we're going to be looking at minimums and maximums when we get to our degree 2 and our degree 3, our quadratics and our cubics. Okay, so we'll be coming back to this. So let's take a look at, okay, here is our degree 1. This is our linear line. This is kind of like this is what you learned in grade 10. Okay, grade 10, we spent like 3 units on linear functions, linear lines, and solving linear equations. Okay, so what I want for you to do okay, so we have to, guys, okay, we have to get to know our functions and what the numbers mean and what they do. Okay, so what's going to happen is if we have a positive leading coefficient, okay, that would be the 2. Okay, that means something. Okay, so I think what we'll do first, okay, we'll label things as we go. Put this on your graphing calculator, and I want you to do an accurate graph in your notes. Okay, so we have 2x plus 4. Okay, so I want you to put this graph. You'll notice where it hits the x-axis, and you can tell where it hits the y-axis. Okay, so we're going to put those in our notes. So, okay, and do your best. If you have a ruler, please use your ruler. Okay, love straight lines. Okay, in grade 10, this is what you learned. You learned that the plus 4 was your y-intercept. Okay, so you might have started with 4. And do you guys remember that 2 was your slope? So slope was rise over run. So if you went 2 up, 1 over, 2 up, 1 over, you could plot this, right? 2 up, 1 over, 2 up, 1 over. Okay. Okay, so you could actually plot your dots just using the equation, okay, and not even having to take a look at it on your graphing calculator. Okay, so here's some things to remember for your y-intercept. Okay, this is where x is equal to 0 for your y-intercept. Okay, x is equal to 0. And if we were to substitute into our equation, we would say 2 times 0 plus 4. Okay, this is why our our y-intercept is at y equals 4. Okay, guys, we write an intercept. Once you've solved the equation, we write it as a coordinate pair, 0, 4. This is where it's located on your Cartesian plane. Okay. So if you're feeling confident, okay, go ahead and draw in the one right beside it. The only difference with the one beside it is it has a negative leading coefficient. And let's see what a negative leading coefficient does. Okay, this is still our y-intercept. Okay, so we're still going to hit 0, 4. But now we're going, okay, our rise over run now, it's negative. So that means that we are going down 2 and over 1. Okay, so down 2 over 1, down 2 over 1. Okay, so we could plot our points. Okay, and connect our dots. Okay. So when we have a positive leading coefficient, our graph is, the slope is what we call increasing. Think of it as climbing stairs. Again, we go left to right. So I'm climbing stairs, and if our leading coefficient is negative, it's kind of like a ski slope, and we get to go downhill skiing. Okay, so our slope is going up, and when it's negative, our slope is going down. Okay, so what we're going to do is, okay, we're still good, right? Okay, we're going to write in some of the details. Okay, so our leading coefficient in this one was positive 2. Now we have to write the description. Okay, so this is, okay, what do I have on this one that I want? Okay, here we go. Ends up on right. Okay. Down on left. Okay, I'm going to write some details and I'm going to talk to you about it. Okay, so the description that I want, and I'll tell you why I'm using 2 different colors. So the description is it ends up on the right because of the positive leading coefficient. Okay, so it goes to up at the right because it's a positive leading coefficient. Okay, and it's down on the left because this is a degree 1. It's an odd degree. Okay. So what you'll find is that there's some similarities between our degree 1 and what we're going to see in our degree 3. Okay, so if it's an odd degree, okay, when we have a leading positive coefficient, we're down on the left. Okay, our y-intercept, okay, is the constant. So in this case, okay, so our y-intercept is the constant. Okay, and our y-intercept is at 0, 4. So just remember the definition of a y-intercept is when x equals 0. Okay, now this is saying the number of x-intercepts. Okay, so there is one x-intercept max. Same as the degree. Okay, the reason I use the word max is because when we get to other degrees, okay, like when we, so this is the same as the degree. So a straight line is only going to have one x-intercept. When we do a degree 2 polynomial, it could have up to 2 x-intercepts. It could have 2 or 1 or 0. When we do a cubic, it's going to have up to 3 x-intercepts, but it could have 2 or 1. Yeah, it'll always have at least 1. Okay? So that's where the word max is, because your how the x-intercept is the same number as your degree. Okay? Our domain for linear lines, so for degree 1 polynomials, guys, there's no restriction on x. X can be anything. So you'll always see this as the domain for degree 1. Okay? And the range, when we look at our line, is there any number that our graph will not eventually get to? No. It goes on forever, right? So it'll eventually like hit all the negative y values, all the positive y values. So a linear line, guys, when you see this, just remember, there's no restrictions at all on a linear line. Woohoo! Okay, done. Every single time. Linear line, no restrictions. Okay? Is there a turning point? Without really maybe knowing what a turning point is, okay? There's no turning point because it doesn't change directions, okay? So no turning points, okay? This is a straight line, okay? There are no minimums or maximums. Okay. So we're gonna look at the one right beside it, okay? It's pretty much gonna be exactly the same thing except for the leading coefficient. This time the leading coefficient was -2. So we're gonna notice that, okay, instead of ends up on the right, it ends down on the right. Okay, and that's because of the negative leading coefficient. Okay, and okay, it was okay up on the left. And again, that's because of the odd degree. So when things are an odd degree, like 1 or 3, okay, we have opposites. Okay, when it's an even degree, we have same. Okay, so I'm probably going to do a lot of like hand signals to kind of help you visualize. Okay, so this way is your positive leading coefficient. Okay, when it goes from, when it starts up and it goes down, that's your negative leading coefficient. Okay, and they're opposite of each other because of the odd degree. Our y-intercept, this one was the same. Okay, it was the constant. Okay, our constant equaled 4, so our y-intercept equaled 4. The number of x-intercepts, 1 x-intercept. Okay. Okay, the domain, there's no restrictions. So let's just get used to writing our domain and range again. Okay, our range y such that y belongs to real numbers. That's how we read it. And turning point, there are none. Okay, it's a straight line with no mins or maxes. Okay. All right. So let's get on to, so a straight line is pretty straight. Okay, let's get on to something a little bit more interesting. Okay. This is the last new stuff for today. Okay, we're going to just look at our degree 2. Okay, our quadratic, or, okay, the shape of the curve of this one is called a parabola. Okay. Okay. Yeah. Okay, so guys, when you graph this, okay, I need accuracy. Your dots actually have to line up with the real dots from the graph. The best way to do this is to use the table of values in your calculator. Okay, so the first thing we're going to do is we're going to enter this one into our calculator. So negative 2x squared. So everybody head over there. Okay, we're going to clear what we had. So we're going to, don't forget, you have to use the negative button, not the minus button. Negative 2x squared. Okay, plus 3x minus 5. Now we can use the minus 5. Okay, let's graph it so we at least see something. There we go. And if you head over to second graph, that will give you your table of functions. Okay, or sorry, your table of values. Used the wrong word there. Okay. Okay. All right. You just need a couple points for your table of values. Okay, and I mean, we want to have things on the graph. So I'm probably just going to choose, well, I could still put -1, -10, right? I think the graph goes till 10. I'll have to count. And then I'll probably put those ones. So just transfer that over. And you can just do it in the column here. Okay. And we have 0, -5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I'll put in the -1. Okay, so -1, -10, 0, -5, 1, -4, 2, -7. Okay, so -1, -10, 0, -5, 5, 1, -4, 2, -7. Okay. One of the things, guys, when we do a parabola that you will need to graph is you do need to have what that minimum or the maximum is. You can do that with your calculator, exactly. So head back over, okay, and you're going to do second trace. That's how you calculate. Okay, guys, is this parabola, okay, let me look at it again. Okay, is this a minimum or a maximum? It's a maximum. Okay, so when you do second trace, you want to make sure that you tell it it's a maximum, and then it just needs you to guide it a little bit, put it a little to the left, put it a little to the right. You guys have done this. So you hit enter for the left bound, move your cursor over a little bit to the right bound, just hit enter again for the guess. Okay, and then it'll like zoom in and it will tell you, okay, at x is equal to 0.75, your value is -3.8. Okay, so I'm going to put that here, 0.75, -3.8. Okay, and this one you can, okay, -3.8. Okay, it's right about there. So that, all right, so there's our parabola. Okay, we have a couple points. We for sure have our intercept. We have our maximum value. Okay, so let's talk about this. Guys, what is the leading coefficient for this one positive or negative? Negative. All right, so the leading coefficient is the -2. Okay, and what happens is, okay, a negative leading coefficient means that we're downward facing. Okay, a positive leading coefficient would be more like a smile, so that would be your upward facing. Okay, so negative leading coefficient, we're going to go down on the right. okay, because it's a negative leading coefficient. This first day, guys, I know there's a lot of writing. Okay, it gets better. Once we have all the like basics in there, it won't be quite so heavy on the writing. So it is down on the right, and it's also down on the left. This time it's because it's a positive degree. So when it was an odd, so yeah, an even degree. When it was an odd degree, we were doing this, we were doing opposites, okay? When it's an even degree, we're either both up, okay, or we're both down. So this is down on the left because this is an even degree. Okay, our y-intercept is still our constant. Okay, our y-intercept is going to be -5, which we found from our table of values, and we could have plotted that right away too. Okay, so it's our constant. Okay, so once you have it, don't forget to put it as an ordered pair, 0, -5. Okay, how many x-intercepts did we have in this graph? 0. It didn't hit the x-axis. It's like hanging out below. Okay, so this is an example where we could have 0. Okay, we're either going to have 0, 1, or 2. The domain. Okay, is there a value of x that's restricted? No. Okay, so for parabolas, the domain, there's no restrictions on the domain. X such that x belongs to real numbers. Okay, x could be anything. However, okay, there's going to be a restriction on the y, because the y gets to a certain point and then it turns around and it doesn't go any higher. So y is going to have a maximum point, and that's going to be your vertex, or your maximum. I use the word vertex because I was just teaching that unit for the 20-1s. Okay, so it's your maximum value. Okay, so our maximum value, y such that y has to be less than that maximum value, and we said it was negative, where did I have it here? See, -3.8. Okay, that's going to come here. 2, okay, like having 1 decimal place is fine unless it tells you that it wants more. Okay, after we have what it can't be, it can still be any number. Okay, it's a continuous curve, so it still can be any other number in y. And then we have to just tell it, is it a min or a max? Okay, and we said it was a max. Okay, and then just tell it where the max is. Okay, so it has a max value at that coordinate, which is what we got from our calculator. All right. I'll hold it there for a moment, let you get caught up. Yes. Yes. All right, our next one. Let's take a look at this guy. X squared plus 6x plus 9. If you're feeling good, put it in your graphing calculator. Take a look at it. Pull up your table of values. Go ahead and plot them. Okay, one of the things that we're looking at, we're going to notice, is this a positive or a negative leading coefficient? Okay, what is the leading coefficient? It just says x squared. Okay, it's 1. Is 1 positive or negative? It's going to be positive. Okay, so this is an example of a positive. Okay, so when we have a positive parabola, right, we're going to have both ends are going to be turned up. Okay, this is still our y-intercept. Okay, so I can go here to my y-intercept. Okay, I'm going to pull up my table of values. I'm going to put these in order. Let me just clean this up for a sec. Okay. -6, -5, -4, -3, -2, -1, and 0. All right. All right. 4, 5. Okay, one of the things that you guys should notice about a parabola is that it's very symmetrical. Okay, it looks exactly the same on one side. Okay, as it, sorry, let me just bring that up a little here. Okay, as it does on the other. Okay, the vertex is actually, if you cut straight through the vertex, that would be your axis of symmetry, and it would be like a reflection on either side. Okay. So we'll notice, okay, our leading coefficient was a +1. Okay, so that means that we are up on the right because it's a positive leading coefficient. Okay, guys, positive leading coefficients are always up on the right. Okay, so that's going to be great. Okay, up on the right. Okay, positive leading coefficient. And it's also up on the left because it's an even degree. Okay, because this is a degree 2. 2 is even. Okay, the x-intercept we said was our constant. And that equals 9. Okay, so that means that our intercept is at 0, 9. Number of x-intercepts. What happens when it like just touches down, kind of like kisses the x-axis and then turns around and goes back up? Okay, how many intercepts are there? Yeah, there's 1. Okay. Any restrictions on our domain? Okay, again with the parabola, there's no restrictions on our domain. X such that x belongs to real numbers. And the range, we just have to figure out what the vertex is. Okay, you can either do that by doing minimum, okay, or in your table of values, we notice that, okay, we hit the axis here at -3, okay, and then went the other way. So our minimum here is our x-axis, right? When y equals 0, so our range is y such that y has to be greater than or equal to 0. For the graph to exist, it has to be, it exists where all the y's are positive, where all the y's are greater than 0. Okay? This one had a minimum value, okay, and it had a minimum value at 0, 3, 0. Okay, now just a quick little note on this guy. Okay, when we graphed it, let me clear that out. Let's see if my calculator will do it, because sometimes the calculators, just because they're graphic in nature, okay, when I graphed this, there it is. Okay, and when I did second trace and I did my minimum, okay, and I went over, whoops, I hit something, sorry guys, give me a sec, minimum. Enter, enter, enter. Hey, guys, if your calculator gives you this, like maybe it gives you some decimals, okay, it is. Maybe for your y value, it gives you something like, 1.3 e to the -12, okay? That's just 0. Okay, that just gets rounded to 0. If you have something strange, okay, it just means it's so infinitesimally small, like it's looking at a pixel, and it just says, well, there is a pixel there, okay, but it means 0. Okay, so your table of values for that example, I was hoping that it would show up just so I could show you. All right, final one. Okay, so we have a positive leading coefficient. So tell me about what it's going to look like. Is it going to be up or down on the left with a positive leading coefficient? Is it going to be up or down? Is it upward facing or downward facing? Upward. Yeah. Okay. So we know that because it's positive, we have an upward facing. Let's get our table of values. All right, so we have 6x, x squared. No, clear. 6x squared. There we go. Okay, plus 24x plus 17. Okay, so you guys should have something like this. You are filling out your table of values. Okay, you need to be writing all these descriptions in, because you'll have to write them out. It will say describe what happens to this polynomial. So all the stuff that I'm writing is not for nothing. It is. Okay, so I'm just glancing around, not naming any names, but some of you have very empty looking notes. Okay, I'm not sure why. You should be writing everything down. Okay, so maybe find a friend who's a better note taker than you are to get caught up. Okay, or pop onto YouTube, speed through the talking part, okay, and write and keep your notes caught up, guys. Do not fall behind. Okay, so leading coefficient was positive. It was 6. Oh, sorry, I kind of got sidetracked here. Okay, I have, okay, -3, -1, -2, -7, -1, -1, okay. Then we're going to have to probably get some decimals going, because this really isn't going to, -3, -1, here we go, -2, -7, okay, -1, -1, okay. We have to make sure that we get our vertex and just a few points. We want to make sure that we know what our values are when x is equal to 0. Okay, so make sure that you head over to your table of values. 6x squared plus 24, okay, that's right. Okay, table of values, there we go. Okay, 0, 17. Okay, guys, this doesn't tell me what my x-intercepts are when my y is equal to 0, because it only gives me solid numbers for x's. Do you remember on your calculator when you do second trace, okay, this number 2 says 0. That's how you find out what your y equals 0 is, okay, and that'll tell you the x value for that. So if you choose number 2, okay, there's 2 of them. We're trying to find out what these 2 points are, where they hit the x-axis. So you just have to guide it and tell it which one you're looking at first. Okay, so I'm telling it I'm interested in this left intercept first. So I go to the left of it, I go to the right of it, hit enter, okay, and it tells me that when y is equal to 0, I have an x-intercept at -3.08. So I'm going to add that to here, -3.08. Okay, and I'm going to head over here and I'm going to do that again, second trace, 0. Okay, and now I got to do the second one. So I'm going to go a little bit to the left of it. Okay, that looks good. A little bit to the right. That looks good. Okay, it zeroes in on it and it tells me that at -0.9, let's round to 2, Okay, negative 0.92. We have another one. Okay, so that's just here. Okay, so we need to make sure that we have x-intercepts. Okay, and our y was at like positive 17, which is like off the, okay, this is a very, very, very steep parabola. Okay, make sure yours looks nice and, okay, it's still a curve at the bottom, it's still a minimum. Okay, but it's very narrow. Okay, so the description we have up on the right. Okay, and that's because we have a positive leading coefficient. Okay, and it's up on the left. And we have that because it's an even degree. Okay, our y-intercept was our constant, which was 17. Okay, x-intercepts, we had 2 of them. Okay, the number of them, we just need to put that we had 2. Okay, our domain, there's no restrictions. Okay, the range, there is a restriction. Okay, guys, we're finishing this up before you pack up. I have 2 minutes. Okay, our range is such that, okay, we need to have our vertex. So our vertex, we have to go back up here. Okay, and we found out that our vertex was here at 0, -7. So our range has to be greater than or equal to -7. Okay, and we had a min value at 0.7. Okay, so the min will help you to set your range. Okay, so I want you tonight and tomorrow study for your chapter test on rational expressions and equations.